Hey everyone. So today, some of you guys aren't here. The way that I planned this lesson is that I was going to have you guys do this first example as a warm-up. So if you want to try to find your derivative and take all your steps like you did yesterday for this first one, turn or pause the video and then come back and then check to see if you have it done correctly. Okay, so you should have done. Remember step one. Oops, I want it yellow. For step one, we have to ask, do we have any holes or asymptotes or breaks in a sine and a cosine? So my answer would be no. Okay, so now I don't have purple and the other colors like I'm used to. So for step two, we need to find our derivative first. So for the derivative, these are two things being multiplied together, so it is a product rule. So my first term is sine, and then the derivative of the second would be a negative sine. And then the derivative of the x is 1. So if you want to put that on, add it on to the second term is cosine. And the derivative of the first would be, oops, I was going to say the derivative of that. The derivative of the first would be cosine x, and the derivative of the x is 1. Okay, so now that I have my derivative, I'm going to shorten that up. So it's negative sine squared of x, and it's being added to cosine squared of x, and I'm setting that equal to 0. Now, just like any other thing, I do expect you to know some of your derivatives or some of your identities. So way up here at the top, do you guys remember that sine squared plus cosine squared equals 1? So I'm using that derivative. You can pick either sine or cosine. I'm picking cosine just because I'm picking cosine. So my negative sine squared of x is going to now be added to 1 minus sine squared of x. And that's going to still equal 0. So negative sine squared, negative 2 sine squared of x plus 1 would equal 0. So sine squared of x, I'm doing a little math at one time, subtract 1, divide by negative 2 would be positive 1/2. That means sine of x, when I take my square root, is going to equal plus and minus square root of 1/2, which is going to be positive 1 over root 2. And remember, these are both plus and minus. Okay, so where is sine plus and minus root 2? It's all four quadrants. And in all four quadrants, those would be sides of 1, 1, root 2, a 45-degree angle. So my sine would be at pi over 4. So it would be at a pi over 4, a 3 pi over 4, a 5 pi over 4, and a 7 pi over 4. Okay, and since I'm dealing with these right now, I'm also going to say, do they make sense? Do they fit inside of my interval here? Yep, they do, so I'm okay with it. So, third thing that I have to do is I have to take that derivative of my negative sine squared x plus my cosine squared x and set it equal to undefined, 1 over 0. Guess what? There are no CP points, no critical points here. Okay, so what do I need? My interval tells me that the smallest point that I'm allowed to look at is bigger than 0, and the biggest point that I can look at is smaller than 2 pi. I'm also going to put down all of my intervals. Now notice I'm doing this in black. Pi over 4, that's going to be a min or a max, hopefully. And pi over 3 pi over 4 is going to either be a min or a max. And 5 pi over 4 is going to be a min or a max. And 7 pi over 4 is going to be a min or a max. So now it is my responsibility to pick a number in between here. So the only number that I know that's in between there, in f prime, I'm going to put pi over 6. That would be smaller than pi over 4. So when I do that, I'm plugging that into my derivative. So in my derivative, I'm going to have negative 2 sine squared of pi over 4. And I'm going to add that to positive 1. Okay, I took this form of my derivative. If you wanted to put it into the cosine squared, it works too. I just chose that because then I don't have to do as much work, and you guys know me. So you guys are going to have to draw out your pi over 4. Oops, I'm trying to find a nice spot for my pi over 4. That's going to have sides of 1, 1, root 2. I'm in quadrant number 1, so everything's positive. This is going to be negative 2 times 1 over root 2, and then I'm going to square that, and plus 1. Remember, my whole goal is to figure out what my answer would be. And when I square this, this becomes 1/2 times that negative 2, and that would be, oops, I need to apologize. I have just done this a boo-boo, and it's good for you guys to see me do a boo-boo every now and then. I put in pi over 4, but what number did I say I was going to pick? So I need to go back, guys, and I'm sorry. I said I was picking pi over 6, so this is pi over 6, which means this, erase it, and let me start again, is going to be a pi over 6, which means that is it over 6? It's a 30-degree angle here, so that's opposite is 1, adjacent is root 2, and the adjacent is root 3, and the hypotenuse is a 2. So that is going to change. My sine value is 1/2, and I've got to square that. So I have negative 2 times a 4th. That's going to give me negative 1/2 plus 1. So my answer is positive. So this region is positive. It increases. I put a big I there. And now I've got to pick a number between pi over 4 and 3 pi over 4. I would pick pi over 2. So I would find f prime of pi over 2. And I'm going to follow that same process of negative 2, the sine squared of pi over 2. Well, here's the nice thing. Sine at pi over 2 is 1. So it's going to be negative 2 times 1 squared. And then don't forget the plus 1 that we had tacked on at the end. That answer is going to be negative. So this region is negative, or it's decreasing. So now pick a number between 3 pi over 4 and pi over 4. I'd pick pi. So I would be doing f prime of pi. And again, plug it in. And at this point, I'm just going to tell you that when I pick pi, it is going to be positive when you work it out, which means that this is going to be increasing. I've got to pick another region between 5 pi over 4 and 7 pi over 4. I would pick 3 pi over 2. And at 3 pi over 2, your answer is going to be negative. And I've worked these out. I hope you guys trust me. And then the last one, I've got to pick between 7 pi over 4 and pi over 2. The only thing I can pick is 11 pi over 6. And when I do that, that is positive. That means this region is increasing. Okay, so I'm the visual that needs to see this. Increasing to decreasing. I know that's a max. decreasing to increasing, I know that's a min. Increasing to decreasing, I know that's a max. Decreasing to increasing, that's a min. So what did I find? My minimum values that are x's are going to be all the bottoms of the valleys. 3 pi over 4, and I think I had another one, 7 pi over 4. Where are all of my maxes going to occur? The maxes are going to occur at pi over 4 and at 5 pi over 4. Okay, so a lot of trig in that one. So now we're switching gears a little bit. There's not going to be any trig, but you need to understand what's going on. So I'm changing colors, changing to red. First thing it says for us to do is use the graph of f prime. So I am going to label this. This is f prime. This is the graph of the derivative. That's what it looks like. And they want us to identify the critical numbers of f. Critical numbers, what do I remember? That's when we take our derivative and we set it equal to 0. Oh, wait. This is where the derivative equals 0. This is where the derivative equals 0. So I can just look at my picture that fast and know my critical points would be at -4 and at x equal -2. That's not too bad. Okay, where the function is increasing, so it asks us to identify it should be where the critical numbers are, where f is increasing and decreasing, and the estimate that our values of x has an extrema. So basically, this is what we need to do. We found our critical points. It's where the derivative equals 0. Red, derivative equals 0. Guess what? These critical points come on my graph. Here's -4. Here's -2. We didn't have to do any algebra to get it. You guys should love this. So now is where it gets a little tricky. So if a derivative is below the x-axis, okay, so now I'm going to highlight that. Do you see this region here? The y values are negative. So guess what? To the left of -4, it's below. That means the derivative is negative here. That means that the original function is decreasing. So let's take a look at what happens if the derivative is above the x-axis. Well, that means my y values are positive. So can you see in this region here that I just circled in yellow, they're positive. The y value is above x. That means this part is increasing. And then let's take a look at this section here. Aren't the x values below the x-axis? So that means it's decreasing. So look, above is positive, below is negative. So now that I have this decreasing to increasing, I know that's a minimum. Increasing to decreasing, that's a maximum. So my minimum is going to be when x equals -4, and my maximum is going to be when x equals -2. That's the changing it and interpreting it as a graph. The key to this is this green and yellow. Oh, Packer colors! I knew you guys would love that. Okay, so let's turn the page. And if you want to try this one on your own, pause it, come back, and then we'll talk through this one. Okay. Okay, welcome back. So the first thing that I need to do is I need to find my critical points. And my critical points are where my derivative equals 0. Okay, so this is my derivative that came in the typing from the other page. So this is the derivative. It is 0, 1, 2, 3 places. So at 1, 2, 3, 4, 5. At -5, there is a critical point. At -2, there is a critical point. And at +4, there is a critical point. -5, -2, +4. Can you see there are 1, 2, 3, 4 regions that I'm going to have to check? Okay, so now I'm changing colors just to change colors. To the left of -4, it's below. My y values are negative here. This region's negative. That means that the function is decreasing. So now, just for the sake of changing colors, look at my next section. Do you see how those are above? My y values are positive. That means this region is plus. It is increasing. So change colors again. I'm almost out of colors. Oh, I went back to red, sorry. Look at this region. It's below. It is decreasing. To keep with the schematic, this last piece here, it's above. It's increasing. So in my head, I go decreasing to increasing, increasing to decreasing, decreasing to increasing. So my minimums are going to happen when x equals -2, and my maximum is going to happen when, oops, -2 is not a minimum. Look at that graph. That's a maximum. My maximum when x is -2. My minimum is when x is -5 and x equals +4. Now, there is one thing that I did not write out in that other one that I know you're going to have to ask. It's going to ask you for the interval where it's increasing. It is increasing bracket -5 to -2, and it's also increasing from 4 to infinity. It is decreasing from -infinity to -5, and it is also decreasing from -2 to -4. This is the newer stuff for today. It means the same thing we did yesterday. Popping back to that first page, and I'm sorry that I had to do this, but I realized I forgot. For this last one, for the intervals where it is increasing, it would be increasing from -4 to -2, and it would be decreasing from -infinity to -4, and it would be decreasing from -2 to infinity. Okay, so you need to take your time and work through these and look at these graphs. So tonight, make sure you do your homework. It's out of the book. You've got access to the book. Good luck.